Hello guys, welcome to coding. So in this video, we'll build a book recommendation system from scratch. So this is the actual demo of the website we'll build today. So here, I'll give the name of the book and it will recommend me 5 similar books related to it. Okay, so let's first understand what a recommendation system is. So in simple terms, a recommendation system is a piece of code that is intelligent enough to predict what a user might like. Let me give you a real life example. Suppose you go to a clothing shop. There will always be a salesperson who will recommend you clothes based on your preference, like your style or what you are looking for. So, a recommendation system is like a virtual salesperson. Many websites use it, like Amazon, Netflix, YouTube, etc. So, there are few main types of recommendation system. So the first one is popularity based recommendation system. It just shows the most popular item like top 10 trending movies or top 10 best selling book to everyone. It's not personalized. And the second one is content based recommendation system. If you watch a science fiction movie, this system will recommend you other science fiction movies. It works by finding items with similar attribute or content. The third one is collaborative filtering based recommendation system. So there are two types. The first one is user based filtering. Um, so this system finds people who have rated products similar to you in the past. Then it recommends product that only people with similar taste as you liked, but you haven't liked it yet. So suppose there are two users, user A and user B. They both like Marvel comic. So user A have read Spider-Man and Iron Man. User B have read Spider-Man, Iron Man and Doctor Strange. So user A haven't read Doctor Strange. So this system will recommend Doctor Strange comic to user A. So the logic is people who like what you like also like this. So the next one is item-based filtering, uh, which is what we are building. Instead of finding similar user, it finds similar book if lots of people who read book A also enjoyed book B. The system learns that these two books are similar. So when you read book A, it will also recommend book B. The logic is because you like this book, you might also like this other book that is similar to it. The final one is hybrid recommendation system, which as the name suggests, it is a mixture of all the above. Most big platforms like Netflix use a hybrid approach. We'll be using book recommendation dataset from Kaggle. We'll use three CSV files, that is book.csv, rating.csv, and user.csv file. Okay, so I'll be using Jupyter Notebook to write the code. Let's give the name of this file as book recommendation system. And let's import all the necessary libraries, that is NumPy, Pandas, Seaborn, and Matplotlib. Okay, now let's import all the CSV files that we have downloaded. That is book.csv, user, and rating.csv. So let's check the content of book.csv. So there is ISBN column, book title, book author, year of publication, publisher, and image URL for small size image, medium size, and large size image. Now let's check users dataset. So here you will find user ID, location, and age. So most is a name. Let's check rating.csv file. So we'll find user ID, ISBN, and book rating. Okay, now let's check the shape of the data frame. That is books.shape. Let's copy this. users and ratings. So we can see in books there are 2,71,360 rows and 8 columns, and in users there are 2,78,858 rows and 3 columns, and in ratings there is 11,49,780 rows and 3 columns. So now let's check the info. Uh, so start info. Uh, so so the D type of every column is object. Uh, let's check of users. So user ID is in type, and other is location is object, and is float type. Check of ratings. So book rating is also of in type. Okay, now let's check if there are any duplicate values in this data frames. So first, let's check of sum. So there is no duplicate values in books data frame. Let's check for user. So there is no duplicate values for user also. Now let's check for ratings. So we don't have any duplicated values, which is good. So now let's check if there is any missing values. So let's check for books. But it's not. So publisher column has two null values, and image URL of Lars has three null values. So let's check of users. So here user, the A's column has 11,762 null values. So we'll not be using these A's column while creating our recommendation system. So we can ignore it. Ratings dot. So we don't have any null values in ratings data frame. I recommend you to perform EDA as you'll have a better understanding about the dataset. But I won't be doing the EDA as the video will go too long. Okay, so before we begin making our collaborative filtering model, so let me give you a brief overview. So we'll have two tables, that is rating and books. So in ratings, we'll have user ID, book ID, and the rating for the book. And in books, we'll only need book name. So the plan is to create a table where the column is users and the row are the books, and the values are the rating given by the user to each of the book. So that's, and we'll have a criteria. So we'll only get the users who have rated more than 200 books, and we'll only get the books which has more than 50 ratings, so that our recommendation system only recommends book that is rated by many users. Okay, now let's get started with building collaborative filtering module. So, so the first thing that we got to do is merge our ratings and books data frame. So uh, we'll merge this ratings and book data frame on top of this ISBN column like this. So we'll get, so this is what we'll get after merging it. Okay, now we have to fulfill our criteria first. That is, we have to get the users who have rated more than 200 times and the books which has more than 50 ratings. So, uh, So for that, ratings with user, ratings with name dot group by. So group by, it will be user ID dot count. So from this we'll get counts. We only need of book rating. So we'll keep of book rating only. We get user ID with the number of book they have rated, and as our criteria was, we'll get the users who have rated more than 200 books. So we'll store it in variable x, and let's do boolean indexing. So we'll only get the users who have rated more than 200 books, and let's get their index. So these are the users who have rated more than 200 books. Okay, so now let's store this in a variable called high rating users. So from now, from rating with names table, we have to only get the users. We have to only get these users. So for that, we'll do something like this. So we'll only get the user ID, which is in high rating users, and we'll store it in variable called filtered ratings. So let's see filtered ratings. Okay, so we have only the users. We have only these high rating users who have rated the books. We have completed filtering based on users. Now we'll move on to the books. So our book criteria is that we'll only select the books which is rated more than 50 times. So it's we'll use filtered ratings dot group by book title dot count on the basis of that is book rating. We'll only need book rating. So we can we'll get book title and the time of and the rating of the book. So we'll need the book which is rated more than or equal to 50 times, and we'll store it in the variable y, and we'll use boolean indexing, and we'll get the index of these books. So these are the books that is rated more than 50 times. So we'll store it in a variable called popular books. Okay, so same as above, we'll only get the books which is rated more than 50 times in filtered ratings table, and we'll store it in variable called final ratings. So this will be our final ratings. Okay, we have fulfilled the necessary criterias. Now we'll create a table where the columns are the high rating users and the rows are the famous books, famous popular books, uh, and the values are the ratings given by each user to each of the books. Okay, now let's create table. So final ratings dot pivot underscore table, and in index equals to in index there will be book title, and in columns there would be user ID, and in values there would be book rating. Okay, let's store it in a variable called pt. Now we have to fill this nan values, so we'll use uh, fillna. So pt dot fillna with values of 0, so in place equals to true. Let's check the table. Okay, we have got our tables. Okay, now let's understand what we have done. So we have created a table where columns are the users and the rows are the books name. So we have total of 810 users and 706 books. We can assume that each book here has a point in 810 dimensional space. Okay, so let's assume this as a 810 dimensional space. So each book here is a vector. So now we'll find the distance between each books and we'll find the similarity between the books. Okay, now let's import cosine similarity from sklearn.matrices.pairwise and let's find the cosine similarity of our PT table. Cosine similarity. So we'll get a 2D numpy array. Let's check its shape. So we have 706 rows with 706 columns. We are calculating equilibrium distance of every book with every book. That is 706 book with 706 books. So let's store it in a variable called similarity score. Okay, let's check similarity score. Let's check of index 0. So we get similarity score of index 0, that is 1984 book with every other book. Now we'll create a function called recommend which will take a book title as a parameter and it will return 5 similar books related to it. So the function goes kind of like this. So it will take book name as a parameter. It will find its index, then it will find 5 similar books, and it will print it out. So let's check out this function. Recommend. I'll send 1984 book as a parameter, and I'll get 5 similar books related to it. So what we have done till now is basic procedural programming. It works fine in Notebook, but it is not very practical. We don't want to rerun all this heavy calculation every time we need a recommendation. So to make our model reusable and efficient, we are going to package our logic in Python class. Think of class as a blueprint. We'll create a blueprint called book recommender that will know how to train itself, make recommendation, and save its progress. So this is the code. First, we have our init method. We'll create our recommender. It initializes 2 containers, one for our pivot table and another for our similarity matrix. So next is the fit method. So we call this, it takes our rating data and does exactly what we did before. That is, it builds the pivot table and then calculates the cosine similarity matrix. Uh, so the next is recommend method. We give the book name and it looks inside the similarity matrix and find the top 5 similar books and return them as a list. So this is the part of our website will eventually call. And finally, the most important part for deployment is save model and load model method. To avoid retaining every time, we use a library called pickle. Pickle allows us to save our trained models, the big pivot table and similarity matrix, that is directly to our file on our disk. Okay, now we are done creating the model. Now we'll make the actual website. So I've already created the files. So let me show it to you. So this is our cf underscore model.py file. We have organized our logic into a book recommender class. Think of this class as our expert librarian. When our website starts, the first thing it does is call the load model function. This function uses pickle to load our two saved files, that is pivot table and similarity matrix. This is like the librarian reading and memorizing. all their notes about which books are similar. Then when a user asks for the recommendation, our app calls the recommend function and gives it the book title. Our librarian then quickly looks at the memory, that is similarity matrix, and find the top 5 similarity books and send it back to our app. So now let's check app.py file. So this is our backend server built with Python framework called Flax. First we import Flax and our book recommender class. Then we load our two saved files, and that is pivot table and similarity matrix. Next we defined our slash route. This is for our home page. It simply renders the index.html file. The other is slash recommend route. This is our API endpoint. It listens for the post request. Our JavaScript on the front end will send the user chosen book title to slash recommend URL. The function then takes the title and pass it to our load memory model. Then it gets all the recommendation and sends it back as a JSON response. Now let's run app.py file and test our website. Okay, so let's write book title and I'll get the recommendation. Give it for this book. So which is great. Okay guys, that's it for the video. We have successfully made our book recommendation system. So I hope you guys like it.